Hello everyone and welcome to today's webinar on energy efficiency for charities and community groups. Just before we get started, if you'd prefer to join the webinar over the phone, you can just select telephone in the audio pane and it will display the dial-in information for you. Also in today's webinar, you've got the opportunity to ask any questions you may have. You can just type these into the questions pane of the control panel. You can send your questions at any time during the presentation, and then we will collect these and address them during the Q&A at the end of the webinar. Today's webinar is also being recorded, and we'll be sending out the slides afterwards, so you have those for your reference. Okay, so I would now like to introduce you to today's presenter, Graham Hunter from the Carbon Trust.
Thank you very much, Annie, and good morning everyone, and welcome to this Carbon Trust webinar on energy efficiency for charities and community groups. Just to briefly introduce myself, my name is Graham Hunter, and I work in the business services team at the Carbon Trust. And as a member of the technical delivery team here, I deliver quite a lot of energy audits and procurement support to a number of charities and community-run organisations. And the webinar that I'm going to deliver today will mainly focus on the zero to low cost measures that could be implemented by these types of organisations. Appreciating that we have quite a broad range of attendees this morning, I've tried to focus on the most commonly found opportunities in this sector for energy saving. But if anyone does have any questions on any more specific areas, as Annie says, please do feel free to ask these, and we will see if we have time to address these at the end. Also, just to mention that this webinar does form part of a series of webinars delivered through the Green Business Fund. And these can all be found on the Carbon Trust website, and they do cover quite a broad range of topics in technology. So I would also suggest maybe having a look at those. So here's the agenda for today's session. We'll start with a brief introduction, then we'll look in general terms at energy consumption in charity and community-run buildings. Following this, we'll move on to explain the key opportunities for energy saving within these buildings, so including heating, ventilation and cooling, lighting, office equipment, catering facilities, building fabric, and we'll also have a very brief look at energy management. Then we'll introduce some case study examples. So I've got one for a charity and one for a community-run farm, actually. So both of which we supported to look at reducing their on-site energy use. And finally, we will also just very briefly run through some of the other services that are available to charities and community groups through the Green Business Fund. And then, as I say, we'll also take any questions that come up at the end. So firstly, just a brief introduction for anyone who is less familiar with the work of the Carbon Trust. We are a not-for-profit organisation with a mission to accelerate the move to a sustainable low-carbon economy. We've been around since 2001, and our head office is based in London. We also have regional offices in Edinburgh, Belfast and Cardiff, and as well as those, we have various offices around the world. So we've got offices in China, Brazil, South Africa, Mexico, and the US as well. And there are essentially three elements to the work that we do at the Carbon Trust. So those would be advice, footprinting, and technology. And the Green Business Fund falls under the advice elements of the work that we do. So first of all, let's have a look at energy consumption in charity and community-run buildings. Energy tends to be one of the larger controllable overheads in charity and community-run buildings. And these buildings house a variety of different activities, and So proportions of energy use will vary according to the type of activity being carried out. For example, say a charity retail outlet might require higher levels of lighting to be able to effectively display goods. At the same time, another example would be a soup kitchen, which might consume quite a lot of electricity on the refrigeration side and in the preparation of food. Many charities and community-led organisations are office-based, but increasingly we do see various different ventures. So I've given some examples there, like museums, art galleries, village halls, retail outlets, hostels, warehouses, hospices, and so on. Occupancy levels and whether the building has air conditioning or mechanical cooling installed will have quite a significant influence on the energy use. And in a building without cooling, generally speaking, the greatest energy user would tend to be heating. Although every charity building is different, there are still a number of universal areas where energy is commonly wasted. So, for example, these would tend to be lighting, heating, ventilation and air conditioning, office equipment, and poorly performing building fabric. And those are the areas that we will focus on this morning. So we'll now look at the various opportunities for energy savings by technology area, starting off with heating. And the heating and cooling requirements of buildings, housing charitable or community-led organisations will differ depending on the building type and use. And heating systems should be designed as is quite common, adapted to suit that need. The building's use will clearly influence the way that heating needs to be controlled. So, for example, a women's refuge providing temporary accommodation for mothers and babies or young children will tend to need to be warmer than, say, a retail outlet or even an office environment. So whatever type of site you are operating, there are quite a few common things to consider. So we'll just run through these, which are bullet pointed on the slide just now. So first of all, avoid opening doors and windows when heating and cooling is in operation. So staff members or volunteers, as well as visitors and delivery personnel actually, normally require easy access to the buildings, but doors left open do allow warm air to escape or vice versa, cold air to enter the building. What generally happens then is that the thermostat senses a temperature decrease and automatically switches on the heating, which might actually be unnecessary. So do try to keep doors open only when absolutely necessary. Maintain appropriate internal temperatures. So ensure that room thermostats and radiator controls are on the minimum settings required for adequate comfort and environmental control. The recommended temperatures for some common charity or community group operated buildings are shown in the table on the slide here, and these can be used as a general guide when setting heating controls. You should also discourage staff and volunteers from using thermostats as on-off switches. Contrary to popular opinion, turning them to the maximum doesn't actually speed up the heating process. All it generally tends to do is just to overheat the space. Investigate and check controls. So where possible, set time controls to match the occupation of the building. Ensure that only occupied areas are heated and that heating is switched off or reduced during non-working hours. Use simple time switches in smaller rooms or buildings to help to automate this process and ensure that time settings are reviewed every month, just to check that they are actually correct for the use of the building. Adjust timers so that the building reaches the optimum temperature just as people arrive, and similarly begins to cool down as people are leaving the building. And this is best done by gradually altering the settings, maybe over a number of days, for example, and just checking the response of the building and the occupants. If the building is occupied for different periods over the week, then we would also recommend installing 7-day timers to allow systems to operate only when the premises are actually being occupied. Keep systems clear and unobstructed. So radiators, fans and ducts should be kept clear of any furniture or other obstructions, and keep fans and ducts clean, and replace any filters at the manufacturer's recommendation as well. Maintain boilers and pipework. So have boilers regularly serviced by a reputable firm. Gas boilers need to be serviced at least once a year by law, oil boilers twice a year, and a regularly serviced boiler can actually save as much as 10% on the annual heating costs. Also make sure that boilers, hot water tanks, pipes and valves are all insulated to make sure that there is no unnecessary heat loss as well. And finally, on heating, consider zoning to match building occupancy and reduce operating costs. So some areas in maybe larger buildings might require different levels of heating. And a solution to this would be to create heating zones in the building where separate time and temperature controls can be installed. So we'll now move on to ventilation and cooling. And it takes energy to heat or cool the air inside a building. If that air escapes through inefficient ventilation systems or through open windows and gaps in the building fabric, then energy is wasted. It also means that more air must be brought in and heated or cooled to maintain the optimum comfort conditions. So reducing unnecessary air loss will save on energy consumption and costs, and also reduce carbon emissions. Many charitable organisations are housed in older buildings, and these typically have a large amount of air infiltration through, for example, floors and windows. So actually might not require any additional ventilation to the natural ventilation that already exists. In fact, some areas of these buildings can actually be quite excessively drafty. And so draft proofing and weather stripping can actually be quite beneficial in terms of reducing energy bills in these businesses, as well as just reducing things like dust and noise levels as well. It is important, however, to provide enough ventilation to remove internal moisture and pollutants, and also to avoid some of the problems associated with things like rising damp. So essentially each building will have its own issues to consider. But again, there are some common recommendations that we tend to make with regards to ventilation and cooling. The first of these being to take advantage of natural ventilation and free cooling. And as simple as it sounds, natural ventilation and cooling just relies on the natural airflow between openings on opposite sides of a room or a building, or rising warm air. Rising warm air being replaced with colder air that's being sucked in through windows or vents, for example. In many older buildings, it's possible to use windows and doors to provide good levels of natural ventilation, which means that mechanical ventilation systems can potentially be switched off or turned down to reduce energy consumption there. Excuse me, but when opening vents, doors, and windows, just make sure at the same time to consider the security implications of that as well. Don't let heating and cooling operate at the same time. So this can generally be avoided, by setting what we call a temperature deadband, which is just a wide gap between the temperatures at which the heating and the cooling are programmed to come on. For example, in an office, the heating might be set to switch off when a temperature of 19 degrees Celsius has been reached, and cooling wouldn't need to come on until the temperature exceeds, say, something like 24 degrees Celsius. So this is a scenario that we've just shown in the little diagram on the slide here. Ensure ventilation controls operate at times and levels to reflect demand. So ventilation requirements may vary at different times and in different parts of the building throughout the day. So check that operating times for ventilation and cooling systems are consistent with the occupancy patterns within the building. Unless ventilation is being used, say, to provide cooling overnight, or particularly in heritage buildings. Sometimes this is actually part of the building conservation strategy. Maintain system components to ensure efficiency. So energy consumption can increase by anything up to 60% if regular maintenance isn't undertaken. Dirty or faulty fans, air ducts, and components, these directly affect the system efficiency and will increase running costs and also the risk of breakdown. So the performance of the whole system should be reviewed at least annually, and replacement parts ordered as necessary. Finally, on this slide, consider weather compensation and optimum start controls. So technology has made it possible now for heating systems to adjust themselves in line with the external temperatures. So a compensator is a form of control for heating systems that automatically regulates the heating temperature based on the weather outside. An optimum start controller learns how quickly the building reaches the desired temperature and brings the heating on at the optimum time before the building is occupied, again, depending on the weather. And these types of controls can potentially actually save hundreds, if not thousands of pounds, and should pay back their investment, normally within the first couple of years. We'll now move on to lighting. So there are many simple and inexpensive ways to reduce the energy consumption and costs associated with lighting, at the same time without compromising health, safety, or comfort levels of the building occupants. So examples of these would be to implement a switch off policy. So all staff and volunteers within the building should be involved in making the energy savings, and this can be achieved by conducting regular meetings, placing stickers above light switches, or just putting up posters around the building. We would stress that it is everyone in the building's responsibility to make sure that lighting is switched off when not needed, and also that failing lamps are actually reported as well, so that these can be replaced, just to help maintain the desired light output, and at the same time provide a safer internal working environment. As mentioned, labeling light switches is another thing that we quite commonly suggest. So light switches should be clearly labelled to help staff, volunteers, and visitors to switch on only the lights that they actually need. And lights in unoccupied areas should be switched off but at the same time, just remember to also consider the health and safety implications of this, particularly in areas such as stairwells. Also maintenance. So lighting is fairly essential for providing a pleasant and productive environment. So it's important to keep things like windows, skylights, and even the light fittings themselves clean. We would suggest replacing any old dim lamps and keeping controls in good working order as well, just by making sure that timers are set to match the occupancy hours of the building. The next step we would generally suggest, once lighting is being well controlled and maintenance is being undertaken, is then to consider looking at installing low energy lighting. So replacing standard light bulbs with LEDs, we're typically looking at around a 75% energy saving these days. When replacing fluorescent office lighting, again, we're looking at something like a 60 to 70% saving on the current running costs of that lighting. Occupancy sensors might be something else to consider. So these essentially will regulate the lighting depending on the occupancy levels of the building. And these can be particularly useful in areas which may be unoccupied for most of the day. So say, for example, storerooms, toilet facilities, or even meeting rooms, for example, can quite often benefit from occupancy sensors. And finally, daylight sensors as well can potentially result in quite significant energy savings. So these are light sensors that can be used to control the amount of artificial light that's coming into the building, maybe where you already have quite good levels of natural daylight. And as these daylight hours obviously vary throughout the course of the year, the sensors will obviously adapt to make sure that you are receiving an adequate level of lighting, but aren't relying too heavily on artificial lighting within the building itself. Another fairly significant source of energy use within these buildings tends to be office equipment. And the growth of IT equipment within many charitable organisations does tend to account for an increasing proportion of the electricity bills. Office buildings will tend to be the biggest candidates in terms of energy savings in this area. But generally, most buildings will tend to have some level of office or IT equipment within them. So recommendations here would include turning off and powering down. So based on the fact that most equipment doesn't actually need to be on at all times, it's important to make sure that it is switched off when not in use, or even just switched to power down mode in order to reduce the energy consumption and also the heat that's actually generated by that equipment as well. Use the most appropriate equipment for the task. So, for example, for internal printing, use black and white printer, or set default printing to double-sided, and try to print in batches where possible, to allow the printers to spend as much time in standby mode as possible. Minimize cooling loads. So again, where possible, place heat-emitting equipment such as printers and photocopiers in separate naturally ventilated areas with good airflow, to help try to minimize the costs of air conditioning, and also to try and reduce excessive noise, particularly in office environments as well. Maintain equipment for optimum performance. So printers and copiers should be checked and regularly cleaned, and parts should also be kept clean and free of dust and blockages. Raise awareness, so make sure that all staff and volunteers are aware, for example, of things like switch off policies for printers and PC monitors. Install plug-in 7-day timers. So these are devices which can be bought for normally just a few pounds from DIY stores, and can help to reduce the likelihood of machines being left on out of hours. So examples of where this could be useful would be with devices like printers or photocopiers, or even actually things like vending machines that aren't refrigerated, that don't need to be on, say for example, during the evenings and weekends. These could utilize 7-day timers to make sure that they are only switched on when there are actually people in the building who might want to use them. And finally, on office equipment, purchase for your requirements. So make sure that you choose equipment that caters for the current needs of the organization. And high-spec computers with large screens and fast processors will generally tend to use quite a lot of energy. So it's always worth just making sure that when you are purchasing this type of equipment, you make sure that you're taking the running costs of this equipment into account at the same time. The next slide we've included is on catering equipment. So whether it's, say, providing hot meals for hundreds of people every day, or whether it's just providing hot drinks in a small office environment, all catering facilities tend to have fairly common areas where energy savings can be made. Usually the largest cost associated with catering facilities is refrigeration, so that's what we focused on this slide here. Fridges and freezers that aren't properly maintained will gradually reduce, gradually use more energy and increase the risk of breakdown as well. So it's always worth just making sure that a maintenance schedule is established for this equipment, just to make sure that energy use and energy costs can be kept to a minimum. Keeping refrigerated produce at the correct temperature is not only better for the food, but can also result in fairly significant cost savings. And energy consumption can typically be reduced by between 2 and 4% if the cooling temperature can be increased by just 1 degree Celsius. So adjusting refrigeration settings so that produce is kept within the temperature ranges shown on the slide here will reduce the energy costs of the refrigeration on site. Regardless of the age or the purpose of the building, most building managers or energy managers even will be able to implement some energy efficiency improvements to the building material itself. Generally speaking, about 2/3 of heat is lost from most buildings through the fabric. So generally through the walls, the floors and the ceilings. So it does make sense, therefore, to improve the building fabric before considering any other significant investments to improve, say, the different services to the building in terms of things like heating, cooling, and ventilation. So common recommendations with regards to building fabric would include insulating to accumulate. So around 25% of a building's heat will escape via the roof if there is no insulation, potentially adding hundreds of pounds a year to the heating bills. So insulating any roof spaces and unfilled external cavity walls as well is a very effective and relatively inexpensive way of reducing the heat loss of that building. Undertake regular maintenance and avoid expensive problems later on. So regular building maintenance should mean that any potential problems are identified and dealt with promptly. We would suggest compiling a checklist of areas to address where energy is lost from the building structure, and just to make notes on where the building fabric needs to be repaired or upgraded. Establish a housekeeping schedule and involve staff and volunteers. So again, maybe just compile a fairly simple checklist to address areas where energy is lost via the building structure. And a schedule should include regularly checking things like window panes, frames, roof lights, and doors as well. And the larger the building, typically the more beneficial it would often be to appoint a specific member of staff or volunteer to carry out this task. Regularly check the building for damp. So damp can cause significant damage to the building structure, but what it also does is it reduces the effect of any insulation within that building. So it's important just to make sure that things like say split down pipes, faulty gutters, or even leaky roof tiles are repaired as soon as they're identified to minimize the potential for damp. And finally, on building fabric, double glazing is now a minimum standard through building regulations when replacing windows. But specifying things like triple glazing, say on north-facing or particularly exposed sides of the building, for example, can offer some additional savings compared to double glazing as well. And finally, in terms of energy saving opportunities, many of these are actually, we find, within the control of the building occupants themselves, which is quite an ideal way, actually, of involving the building occupants and raising awareness of the importance of reducing energy consumption. So without going into detail on energy management, for which we have actually run a separate webinar, which I would recommend if that's an area of interest. What we'll do is just on the slide here run through some general housekeeping tips on energy management that would apply to most organizations. So first of all, responsibility and commitment. So to effectively implement a change in practice, senior management personnel through to frontline staff must be committed to energy efficiency. And this should be backed up by a tailored mission statement and an energy policy for the organization. It's often quite useful to appoint someone as an energy champion. So in most small charitable or volunteer organizations, this might be, say, an office or general manager. And in larger charities, for example, this might be actually a specific member of the staff who is not a member of management who has been asked to carry out this task. Which leads neatly on to involving staff. So all staff members and volunteers are important in saving energy. So they should be made aware of wastage areas and be trained to operate equipment and controls correctly. Record and understand your energy consumption. So understanding energy consumption by reviewing energy bills over the last, say, 12-month periods will enable you to build a picture of past performance, and then also hopefully you would then be able to predict future energy consumption based on previous performance. It's also important to set targets and tell staff how much energy is currently being consumed on site. As the energy saving program gathers momentum, it should be possible to compare current and initial consumption. So then you could actually look at highlighting energy savings or performance improvements to staff and volunteers who are working within the building. Check energy consumption out of hours. So if a building is empty overnight, then it's quite often worth finding out just how much energy is actually being consumed when no one is in the building. A simple way to do this would just be to take meter readings at the end of one day and the beginning of the next. And then just have a look at the difference between the two readings, and this will show you how much energy is being consumed overnight. And quite often that is more than was expected. So it's, as I say, always worth a little bit of investigation on that point there. And finally, ensure to undertake regular housekeeping walk rounds. So just make sure that walk rounds are carried out within the building or on site at different times of the day, just to get a better idea of where and when energy is being used and potentially wasted. So look at different patterns of energy use throughout the day, and then note down and act on any issues that have been noted, for example, any maintenance measures that might be required. So that brings us to the end of the section on energy saving opportunities. What I will now do is just briefly introduce two case study examples of projects that have been implemented. And as I mentioned, so one of these is a charity and the other is a community volunteer run organization. So this is an example here of where we worked with a charity who provides employment experience for adults with a range of disabilities. On this project, we initially carried out an opportunity assessment at a warehouse facility that they operate. And through that assessment, we identified some potential to upgrade the lighting and heating systems that they had on site. So they were fluorescent linear light fittings, and they also had some fairly inefficient gas-fired warm air heaters. So they actually came back to us and asked us to engage some of our accredited suppliers in a tender process. So we did that. We reviewed the proposals that came back for LED lighting and top specification gas-fired warm air heaters. And the the proposal they actually decided to go ahead with had a combined annual saving of £3,500, and the project overall had a payback of just under 5 years. Second case study example is of a community-run biodynamic farm. So again, this organisation asked us to carry out an opportunity assessment at one of, I think, 2 sites that they actually operate. So this assessment identified quite a number of recommendations. And the top 2 recommendations identified were to optimize the use of a thermal store that they were using within the dairy facility, and to replace 6 condensing units that they had on site that were connected to the refrigeration systems. Again, on this project, there was a combined annual saving by implementing these measures of £6,277, and the payback on the investment in this equipment was 3.7 years. So now that we've given some examples of the energy savings that can be achieved, what are the next steps for charity and community groups attending this morning's webinar? Well, we've listed some of these as bullet points here, which I'll briefly run through. So the first step would generally be to understand your energy use. So as we've described, look at the building and identify the major areas of energy consumption. Then identify the opportunities. So compile an energy checklist like the one shown on the slide here. Then prioritize these actions. So draw up an action plan detailing the schedule of improvements that need to be made, and when these need to be made by, and who is ultimately responsible for these. It may be that you need to seek some specialist help, and I'll run through some of the services that we can actually offer through the Green Business Fund in just a second. Make sure that make the changes and measure the savings. So it's important that once these measures have been implemented, just to measure the impact of these and make sure that the expected savings are actually being achieved, and if not, to address this as well. And finally, continue to manage the organization's energy use. So for example, enforce any policies that have been implemented, or any system improvements and procedures that have been implemented to ensure that the building operates as efficiently as possible and that savings are maintained in the future. So that brings us to the end of the main content of this morning's webinar. To finish off though, we'll just briefly run through some of the services offered through our Green Business Fund scheme. So the Green Business Fund is a scheme available to small and medium-sized businesses, schools, sole traders and charities in England, Scotland and Wales. Businesses need to meet 2 of the 3 criteria outlined on the slide shown here, and also have no more than 25% of their business owned by an entity that does not meet the SME criteria. The Green Business Fund offers energy efficiency training, normally delivered through 2-hour workshops, and these are hosted across the UK. So we just listed the upcoming workshops on the slide here. And these tend to outline energy efficient behavior and equipment to help reduce the energy consumption within your organization. We also, as mentioned during the case study examples, are able to offer opportunity assessments. These would either be delivered remotely or on site, depending on the size of the organization, and would be delivered by one of our consultants here at the Carbon Trust, and are typically designed to come up with some costed recommendations for reducing energy consumption at the site. We also offer an implementation advice service. So this is the managed tender process that we mentioned during the case study examples. And this is really aimed at organizations who already have a plan of which measures they want to be able to take forward. And it allows one of our consultants to work with the organization to actually go out to tender on a project and to get quotes and proposals back from some of our accredited suppliers. We also are currently still offering a capital contribution through the Green Business Fund, which is typically 15% towards the total cost of the energy saving equipment. Just to flag though that that is a fairly limited pot of funding, which is expected to actually run out in the short term, but as I say, is still currently available, and it's targeted at organisations looking to implement energy efficiency projects, which have a payback within normally a 5-year period. Just some additional services to run through fairly quickly. So we have a virtual energy manager service, which is a one-on-one tailored service of modules which are delivered usually over the phone by one of our consultants to try and identify savings associated with energy management. We also offer a number of technical webinars like the one we're delivering this morning. As I say, these are all available via the Carbon Trust website. And finally, again, available via our website, we have a range of publications and advice aimed at supporting organizations who want to look at becoming more energy efficient and trying to reduce on-site energy consumption. We also more recently have been developing a carbon footprinting calculator, specifically aimed at small organizations. So again, that is available via the Carbon Trust website for anyone interested in having a look at that. And one very final thing just to flag is that the Carbon Trust also manage something called the Energy Technology List, which is a government-approved list of energy efficient products. And there are more than 15,000 products listed within 57 technology categories. For example, refrigeration, boilers, motors and drives, heating and ventilation. And any organisations that pay income or corporation tax can claim enhanced capital allowances on purchases of energy technology listed equipment. So that brings us to the end of today's webinar. Thank you all for your time, and I hope that everyone managed to take something from it. We still have a little bit of time left, So what we will do is I'll pop myself on mute for just a couple of minutes to see if any questions have come through. And if we have any questions, then I'll come back on and offer some answers to those. Okay, so we have had a few questions come through, so I will just answer those. They should all be fairly quick responses, so we should be able to get through those just now. So the first question was, is the Green Business Fund available to charities of any size? So the answer to that would be, as long as the charity meets the SMA criteria that we listed on the slide here, which is also listed on the Carbon Trust website as well. If you do have a query about a specific charity, what I would suggest is just if you do go onto the Carbon Trust website, you could either give us a call, or there is actually a live chat function on the Green Business Fund page as well, where one of our advisors would be happy to give you a bit more specific advice on that. But generally speaking, as long as the charity meets the criteria listed on the website and on the slide that we had in this presentation, then we should be able to provide Green Business Fund services. The other question related to Green Business Fund was, what are the costs for opportunity assessments, etc.? If on the Carbon Trust website, could you please send a link? So the opportunity assessments and the implementation advice and all services offered through Green Business Fund actually are free to any organisations, as I say, that meet the criteria listed on the website. So they are free to any charities or community groups who meet the UK government definition of an SME. The final question that's come through was, I work in a 20-year-old building that is in need of new boilers and electric. It's a large building. Typically, how much does it cost to go to LED, and what options are there for energy saving boilers? So to address LED, first of all, costs will vary, normally depending on the scale of the project. But a general rule of thumb, I would say, would be that we are seeing currently prices sort of between probably 1,500 and £3,000 per kilowatt of LED lighting installed. So that hopefully gives you a bit of a ballpark figure to play with. Another ballpark figure is probably so per luminaire. Normally we're looking sort of between 100 and 150 pounds for full replacement and installation with an LED equivalent. But as I say, costs will vary just depending on the scale of the project and the type of site that you're operating as well. Again, I would suggest probably getting in touch with us via the Green Business Fund area of the website, and that's certainly something that we can help you with having a look at. Options for energy saving boilers, assuming that it is a gas boiler. So modern condensing gas boilers have seasonal efficiencies of up to 91 to 91.5%. So that's normally what we suggest if you are looking for a like-for-like replacement of a commercial or domestic boiler. Depending again on the type of site, it may be that you would take the view that that's not actually the most appropriate solution for that site. So, for example, if you're trying to use a gas central heating system to heat a large warehouse site, that's usually not optimal. Usually there we look like at something like gas-fired warm air heaters. So with any technology solution, it's important just to make sure that what's being specified is actually appropriate for the site. Again, I'll just come back to the point that if you did want to look at implementing LED and heating upgrades, then I would suggest just contacting us through Green Business Fund to see if we could actually assign a consultant to that, and then we could have a look at that in a bit more detail with you. Those are the only questions that we've had come through so far. If we do have any further questions, then we're very happy to follow up on those over email. So please do feel free to get in touch with us. But otherwise, I will leave it there in terms of the webinar. And once again, thank you all for your time this morning.
Thanks, Graham. Thank you.